Just a quick overview here of what we're going to look at. You probably have seen some of the material already. I'm going to demonstrate some visual effects for a character attack using Niagara and Unreal 5. And one of the things I want to go through in the time we have is just a part of how things are built in Niagara, how we use them in Sequencer to showcase the effect and work on it in a basic level, and try to explain a little bit of the process I was thinking of in designing this. One of the things we won't have time for to get into today, but would be covered in the workshops in person, is the ability to take it to the next level. How would you want to develop your effect based on some of these techniques? And I could work with you and explore those further. A lot of the things I'll show today we'll just touch on, but we would have more time in class during a workshop to really explore further. So just bear in mind we may not get to every bit of this process in showing this effect, but this would be a good example of what I would cover in the morning, say over 3 hours, and then we'd have an afternoon to work one on one and explore it. And you could continue with that technique or those ideas later in the week as well. Each day would have some new content, but we'd also have the ability to continue to work on the things we covered already. So let me start. I'll do the sharing, optimize for video clip, and just let me know that you guys are seeing that. I have to show meeting windows here. All good. All right. So what I'm going to show here is we're in Unreal, and I've built out a basic sequence that, again, is just in this tab here. And then our content browser, if you're familiar with Unreal, is tabbed over here. I'm also then going to slide into our window, our Niagara system, and I'll explain what's going on with the Niagara system while we're looking at the effect being played in the sequencer. Some of the things I like to do, most of the times I like to develop the effect in Niagara inside of a sequencer playing in a mock-up simple environment, basic lighting. And that helps instead of just working in the Niagara window, displaying just that effect against a black background is okay. But a lot of times I need to see a little more of the scale and the context of it being in an environment. So I'm not going to get too involved in showcasing how we set that up in Sequencer, but it's pretty straightforward, and I'll, point out a couple things as we go. Right now, if we just play our sequencer, we'll see the little movie basically of our character's attack. And again, this is something that was all built in Niagara over a couple different systems. And I'll go ahead and break these down and showcase what's going on with each one. One of the keys, like I mentioned, is to have some idea of what's about to happen with the visual effect before it actually happens. Sometimes it's just a quick couple frames, sometimes it's a more energized build-up based on what the animation may be doing, but it helps give a telegraph or a look ahead to what is going to happen. And then after the actual effect occurs, having some residual aftermath. Again, maybe just a couple frames, but it doesn't just disappear unless it's meant to be maybe an impact or something very punchy and very quick. This effect I wanted to kind of slow down to really show, okay, we're going to illustrate, we're going to showcase all the motion and the shapes and the color. In a game, this might happen where it goes twice as fast, but it's still important to remember those ideas of like, you don't want it just to pop on and pop off. especially if it's meant to be a sort of powerful attack or something that's, meant to, might have a chance to get out of the way of the attack. So something to think about when you're designing in your mind or sketching out ideas for visual effects. Again, I'm not going to get too much into our interface here for Unreal. I'm going to just jump right in to looking at how these effects were built. And what I'll do is, if this is okay for you guys to see, I'll just zoom in on certain emitters, and then we'll see a little bit of that in the window here. That's not so important. We'll see it also reflect in our playback in the scene. So one of the things that was a key component in designing this was I wanted to have the character conjure something powerful out of the ground, and it was going to be rock. It was going to be of nature, and it was meant to be dangerous looking. So I wanted to have it spiky rock elements, and it was going to be something that would have some glowing magma as well. So I knew basically how I need to approach this was building a system, and I'll show you here. This is what I call the ground spike attack is our Niagara system. So I always begin those names with NS so I could see it anywhere in the editor or search for it. I know it's a Niagara system. And I placed it into this sequence to just time it with what the character is doing. If I play this a little bit, I'm going to change what's the desired age will allow us to not have it tick all the time. It'll only tick when it's actually like I can freeze frame it, which is useful, having desired age on the life cycle. We'll explain more of that in the workshop. But I can see now that element there is this effect here, so that Niagara system. The other system I built was the anticipation effect, and I can mute that so we won't show that up. So if I go back again, you may not notice, but there's no warm up now. It's just the effect itself. And so I like to simplify and look at things as I build them in isolation often. So I don't need to have everything playing at once as I'm designing the effect. So with that idea, this system, I'll zoom out a little here. Hopefully you can see this system, the ground spike attack, is actually several emitters. And I also like to use, just a bounding box to sort of organize. These emitters are all related to what I'm calling the ground strike action. And then down here, this bounding box is going to be the emitters that will be the aftermath of what happens after the attack. So building this out, I really wanted to create the spike elements first and focus on that. So I'm going to just select this emitter and we're going to isolate that. And what that'll allow for, I often have to save this. By saving in your Niagara window here, it will ensure that it'll update properly in your sequencer, in your level. Sometimes you don't have to, sometimes you crash. So I often just take extra little steps of like, okay, let's save it. And now I'll play this again where we're only going to see that one emitter. So we don't have the cracks in the ground. We don't even have all the rock spikes. We don't have the dust. It's just this one that's been isolated. And because of that, now we can sort of explore this a little bit more as to what was going on to build it. And one of the keys I was trying to solve for is to have an attack where I can very clearly move these spikes to a certain distance, have a certain height, and a certain sort of angle. And so to do that, I did, again, hopefully you can see this I'll make this window a little bigger now. I did this with one emitter, and then I created a version that was a right-hand side and a left-hand side. So with this, I'm going to just step away and uncheck these modules that will show what was changed to create this. Uh, as an overview, basically, I'm trying to emit these particles in one burst. So I burst 55 of these at once. And then I want to move them very quickly, but not with forces. I want to really just relocate them. And so I will then, during the particle update, use a shape location, which is what we use typically for when we create the particles where they're born, but we can also animate the shape location over the time of how long the age of the emitter is. So basically in seconds. And with that, I'm able to, if we just bypass that off, I have our cylinder here creating all of these spikes. They're not big, they haven't been scaled up yet. And then the shape location during the update is going to move them, and then they're going to also be scaled. So if I tried to do that with a bunch of forces, like traditionally we would do, you have forces moving particles. You don't have a real control of where they're going to go necessarily, or when they're going to stop moving necessarily. And this is not meant to be that type of an effect. This is might be more of a very quick, very deliberate placement of an effect. So I'll just step through the remaining bits here to sort of understand now how are we getting the shape now that we understand a little bit of the size. And also this is a little bit involved, but we'll dissect this. Basically, when you create a shape for where your particles are going to be born, you're going to have choices. Is it a box? Is it a cylinder? But with the box, I'm trying to take a box and I want it to change the size in X. And X is always pointing away from where the effect is coming out of. So it's forward basically. So I want my X value of my box to start at a value on this curve where on 0 seconds, it's 50 units, 50 centimeters. And so that's where this side of it is, if you can see that, the closest side to the character. And then after a certain amount of time, this other keyframe, 1/3, 0.3 of a second, now X is going to be 300 units. And so that gets me to this other edge. So it's allowed to go from 50 to 30, and that is updated every tick over the course of 1/3 of a second. And then I can also decide, well, maybe I want it a little bit longer, maybe I want it a little bit less. I could change that 300 to be a different number, or I can also scale the curve. So the scaling the curve right now is set to 2, and if I set it to 1 instead, you can see hopefully that was half the size, half the distance, right? Or I could scale it to 4 and it stretches it out to, twice that distance. Now it starts to break apart, right? Because it's the same number of particles, 55 particles that were spontaneously born. So I find a happy medium, the good fit for the distance. And usually this is what a designer will ask for. They'll be like, hey, we need this attack to reach out and hit the opponent at this distance. And so in this way, you can very quickly, or not quickly, but you can build a system that allows a lot of quick changes in iteration that'll help achieve that goal. So once I have that decided, the distance, I also want to change the size of the spikes. So you can see it's growing larger as they get farther along. And that's the goal, right? We want to have the big, dangerous parts of this out front where they would hit the opponent or hit the environment, and the smaller bits are closer to where the character was. So to that, I can then take and use a scale. So I'm going to scale mesh size by distance. That's a module you can create. It's available when you look under particle update. And in that way, again, I'm going to have a curve so that I can decide, okay, here, when the distance is just 1, the scale of these shapes will be 0.25. And then when the distance traveled is 149.19999 whatever, 150, then they've gotten to 1.75. So again, these numbers I could type in, this is just a keyframe to change that value. Or again, I could change the slope of this if I wanted to be more dramatic or less dramatic. You know, these are things that will update and influence the finer points of the look. So these are things I usually save for later, further refinements after I'm happy with the overall shape and timing. But essentially, that too will update based on how far I travel those spikes. So that's another bit that's procedural. As far as they go, that distance they go, we should be able to modify that slope and that value. And then finally, I've created what's called a dynamic material parameter. And I'll come back to this a little bit later, but this is a way of taking some controls from our Niagara particle system and influencing the material that is going to be on these spikes. And I'll show you that material in just a few minutes and why we create this dynamic material parameter. It's going to allow us to erode away, dissolve away the spikes at the end of the lifetime of the particle. So a lot of times I don't want to have things pop on, I don't want to have them pop off. And oftentimes we're faced with that challenge in a game that you've made all this geometry in your effect, and maybe it's collided and fallen on the ground, but you don't want it just to disappear. It's kind of fake in that way. So instead, we'll often use a material and a mask on the material to erode or dissolve it away, maybe with a little dust, like you saw in this demo movie, and that helps um, sort of resolve that look. And then finally, we have the mesh renderer. So at the end of doing all of our particle, we've born particles, we've moved the particles. How are they going to be represented on screen is our mesh renderer. And you basically have two choices. You have a mesh or a sprite renderer. And obviously this is a mesh because these are real pieces of geometry. So in this way, I don't want to have the same looking spike repeated over and over. Just like the entire effect, you always want to try to make it feel natural or not mechanical usually. It has no repetition, there's no straight lines generally. So I'll use more than one mesh as a choice to copy onto the particles. And in this way, I've built a couple, actually just stole them, and I modify their materials, but they're different shape meshes. And so if we look at one of these, you can hit our little browse button, and then back in our content window, we can see that guy there. If we open up this mesh, there's not, where's my window? There's not too much here to really showcase, except that it has the material on it. And we'll look at that. But it's basically someone modeled this spiky rock formation. And I have a few of them. So in this collection, I had chosen two, number 3 and number 4 to use. So how how do I choose? How do I have more than one? So what we can do in our mesh render is you can enable what's called a mesh flipbook. And what that'll do is you are allowed to have more than one mesh be looked up and used randomly being assigned to your particles. So this is a relatively new feature, but it's nice because basically I point it to my one rock, a static mesh, and it knows to pick up number 3 because I chose that, and then the next one in order, number 4. And as many as there were, if they had 20 of them, I could, have 20 of those if I chose to. I only wanted these 2 because I don't need that many. But it gives you a little variation, gives you some variety, which again, we do this a lot where we want to have, rocks not look all the same on your particles. A mesh flipbook is a good approach for achieving that. Okay, so that's basically what's going on with this one effect for the rock spikes. And then what I do is I create the same emitter. I basically copied and pasted it to make what's the other side of it. So it may be hard to see, but oops, especially if I do that. But this is only one side of the effect, what I call the right side. So I will also go ahead and isolate so we see the left side playing now as well. And we go back to our sequencer tab, do a little reset. I'm going to save because that usually makes it more stable. And now we see that it's a more full spike attack. So why did I make 2 of these instead of 1? And partly because I just wanted to be more particular in controlling the slope or the angle of the spikes. I didn't want them to always be randomly going every which way. And so I'm able to do that because in our where we birth the particles in our particle spawn, both of these have a mesh orientation. So what this allows for is like, which way do you want your mesh to be facing when it's pointed, when it's assigned to your particle? And in this way, it's going to be a little bit hard to tell the difference here. But I had a different, sorry, this one. I had a different value set up for the left than I did for the right. It's very slight, but again, if we have time, I'll come back to showing you. We can rotate these spikes so they're not absolutely straight. They can go a little that way, a little that way. And because I have a right and a left, I can make that an easy choice to rotate them a little bit away from center is all. And this does not cost really anything, right? So this is not an expensive process to do. I've only, I'm creating a CPU particle simulation, but I'm only birthing 55 particles. It's nothing. So that extra little bit of control I would not have gotten if I tried to do it all in one emitter and tried to find some clever math or some complicated process. I just said it's easy enough to have them go this way and then duplicate that emitter, flip the value around to go that way, and then they're both all facing forward basically along X. Okay, so then I'm happy with that. The big pieces are established. Now I just want to complement what else is going to happen with this effect. So we'll just continue to add more of these emitters to be viewed by just right-clicking and saying isolated. And I'll do our little save. And then let's shrink this guy up. Come back into here. So typically, I don't want to have an effect of geometry just intersect my terrain, my environment. I want to dress it up a little bit like there's some other effects kind of hiding where that intersection occurs. So one way of doing that is having another collection of particles, in this case just rocks, populate that same area and that same space, the box location that's expanding, um, but a little bit wider than where the spikes are. So we have what's hopefully a consistent edge around these big spikes. We'll have some smaller, hot, molten rocks coming out of them. And because our particle systems are randomly being spawned every time they regenerate, which is fine usually. You don't have a exact look the same time every time. But you generally want to get it close that covers most cases. So sometimes the rock spread is better than others, but it's not the key part. The key part is really where are those big spikes going and are they, achieving the visual goal. But without the rock debris, I felt like I just see a bunch of hot molten spikes coming out of a perfectly undisturbed ground, which is usually not desirable. So the role of this is again just to fill that out. And this has really the same approach in building the emitter of the spikes. What's a little bit different is that, again, I'm not scaling these up per se, but I am doing, again, the dynamic parameter, and I'm also rotating these as they're updating. So I'll do a quick demonstration of why I'm doing that. A lot of times when you're trying to create effects that have energy and feel, exciting, if you just move pieces around and you don't rotate them, it feels very artificial. So this little added rotation, update mesh orientation, allows these rocks to have a little bit of a spin to them, as it were. Um, and then they come and rest, right? So this isn't doing anything with dynamics. It's not colliding with anything, but it's adding a little extra motion that goes along with the spikes coming up out of the ground that helps, I think, to sell that um, feeling of energy and motion. Otherwise, again, this is basically the same setup. So let's put these guys back into play. And then we'll do our quick save here and move down the line. So now the rocks are taken care of. We do need to dress up a little bit of what we would create would be dust. And so we're going to show our dust. Yeah. And now again, I just mix this up a little. It really isn't that big a deal. In this case, I made this a GPU particle emitter. But at the same time, it's not really necessary. I'm only spawning 25 particles, but I just wanted to do a little bit of that in case. Generally, when I'm creating particle effects that are not meshes, and I may need a lot of them, a lot of sprites, they'll end up being GPU particles, and they're dumb particles. They don't have to do anything very clever like special collisions or spawn particles when they die. They don't have to do anything very clever that way. So all this is adding for us is, in addition to our rocks on the edges, we're getting a push off of dust now. So we can see just a little bit of that happening above the ground, and we have some basic collisions here, sort of to finish the look, oops, of that attack. And in this case, this is unlike the other emitters. This doesn't deal with creating a box and animating it. It's really using traditional particle forces. So if we just take a quick look at that, again, we're going to spawn these because we want this all to be one big burst. It's offset in time slightly. So what each emitter can do within a system is if you want that emitter to do, let's say, flying debris, a little bit later than the rest of the effects getting triggered, you can control that in seconds here. So a lot of times I don't want everything popping at once. I want a little bit of beginning, middle, and end even in one system. So that's useful. And then again, we create where it's going to be born, this location. And then we also, if we look at initialized particle, this is where a lot of the settings are dictated for what your particles are going to have for characteristic. In this case, this is mesh. So we're determining the size range of these rocks so we can have them randomly different size. I can also show you at the workshop how we can create a very deliberate look where we can have most of the rocks a certain size and a smaller percentage can be larger. That happens more in nature than just random. And then we can look at the point value or attributes like lifetime. These are not meant to really live past the life of the system because they're rocks. So again, I just give a basic lifetime for that. But oftentimes, even with sprites, most of the time, we'll have a random range of the lifespan. And then finally, again, we create the particle to have a variety of rocks associated with them. So what we do is we dictate in our particle spawn an index value. An index value says we're going to assign an integer value between 0 and 4, and that's going to be the number that you get assigned for the rock that gets copied onto you. So like with the spikes, I'm using a mesh flipbook, but this time I'm using 5 different rock shapes, different static meshes, and that gives you a little variety. And also then we've dictated that in this mesh index, we can have 5 different types of static meshes, 0 to 4s, 5 different ones. And that's important too. Again, all those little subtle details gets you a more natural look to your effect, and it's not something that you can see the same thing easily repeated. And then finally, again, as a traditional effect, we're going to have forces like gravity affect them. We put on some drag, we put on some rotational drag. We're also rotating these. We're having the orientation, the initial mesh orientation different. So again, it doesn't look uniform when these things are spawned and flying. And then finally, we have a collision module that allow these to collide with the ground like they're doing. For what it's worth, the collision module really doesn't work in your viewport in Niagara. I always test it in a level with actual environments to work on. So that's essentially the attack, the ground spike attack. And then I'll just briefly go over the aftermath. And then what we can do with that now is we're going to take and no longer make these isolated. So we can shift select all those, and then we can shift select these to just look at the aftermath. I'll do a quick save and then play this again. So obviously no spikes now, but what we have is what will be left over. And part of this is I always feel cheated after seeing a great effect and it goes away and there's no follow through, there's no aftermath. So this is something that again I'll show more in depth in a workshop, but it's important to have separate components represent what should be happening. So the first one, this first emitter is dust. So we would have a little bit of dust crumbling away from our big spikes. And you can kind of see that hopefully a little bit here. These were built, this emitter was built with the idea that we're going to, in the same space the spikes occupy, we're going to create these particles, but I made it into a cone shape instead of a box shape, right? Because if you look at the spikes that were being spawned, it was a bit of a cone because the small ones near the attacker and the larger ones near the victim. This is okay. This approximation of shape is fine, just to have that space generally where those spikes would be. And then in this way, we're birthing particles all at once, spontaneously. But what I like to do is I have the intensity or opacity of the sprite ease in. It doesn't pop on as soon as it's born. So in our scale color, what we're able to do is we can scale the alpha. Like I don't need to change the color, but I want this particle when it's born to be basically a 0, 0 value. So no opacity, no alpha means it won't be visible. And then after 1/10 of its life, normalized age goes from 0 to 1. After 1/10 of its age, it'll go up to being opaque. And then that allows it to show up without popping on. And I'll also do that with things like the size of the sprite. I don't want to pop on a very large flipbook sprite when a particle is first born. I usually want it the same as the alpha. We start with a very low value, 25% of its scale, and then pretty quickly it goes to the size I want it to be. In this case, I put it up to 3. And in that way, hopefully, you'll be able to see, or maybe at least in the movie, they sort of appear magically. They're falling and appearing. They're not appearing and then falling. So that, again, little things like having these curves control some of those options like opacity and scale help a lot. And then finally, because this is a flip book, the sprite render is looking at a material of a flip book of these sprites. They evolve over time, so we have what's called a sub-UV animation module that will flip those images and go through that 16 images over the life of that particle. And then some other basic things we do often is add a little curl noise in addition to the gravity. And then I always like to have rotation on a sprite. It can be subtle, but again, I don't want to just see things sort of move in X, Y, and Z. They do need to sort of, especially a smoke or dust thing, needs to feel like it's sort of swimming around in space. A little rotation helps with that. And then I do a falling debris. So this, again, our rocks that are falling are meant to be what's left over of our dissolving spikes. And so in that way, I'm using like the falling dust, but with a mesh renderer. And like I mentioned before, we have a flip book of mesh shapes that we can use. And we have those basically like we did with the falling dust being spawned, and then in the same shape, same cone shape, and then colliding, right? So we have a collision module for them. And then finally, the last bit is we created this big fissure. These molten hot spikes come out of it and fling, some debris with them. We have to have something left over to sort of show that there was something there. So this last one is creating a sprite of a piece of art of cracks and multiples of those with a material on them that allow it to glow. And then over the time of the particle with the dynamic parameter, it'll fade to black, like it's a scorch mark now. But it's the same piece of art as the glow. And over the life of a particle, then I can have it feel like it's cooled off and then fades away, basically. In this case, it's popping off because we're just clipping the end of the sequencer animation. But for me, then, having these elements remain gives a little bit of a logical conclusion to this attack. And it depends. You may not always have that opportunity in a game to do all that, but it's nice to be able to know how to do it. And especially in cinematics, that's a thing that'll add more to the storytelling or more interest to the visuals when there's time and place and performance overhead to do those things. So I'm going to conclude with that. Like I said, this is just the one emitter. The other one we're not going to get to is the anticipation effect here, which again is built using the same approach, but just creating what will happen before this bursting of our spikes. Um, and it's meant to again sort of give the player some idea of like where is this attack coming from, or where is it going to be located at, and it also like what's going on with his hands, those effects is part of that storytelling. Like I'm going to summon something and the ground around me is already starting to crack and glow and have some thing come from that. And I'll create those as separate systems because of the timing often. And what typically happens is either your designer or your gameplay engineer will take your systems and put them into the game itself, maybe through blueprint setup or maybe through some scripting, and they'll noodle the timing typically. But for us, when we're creating effects, when I want to look at a demo reel of an effects artist, I want to see just what we're doing here. I want to see that you get the timing, you understand the anticipation and the aftermath and the attack, and you've refined those skills as much as the visuals of like putting the right components together. And I find working with a sequencer setup like this, it's very easy to make that story, tell that story, and not get bogged down with how will we play this, or does this perform in different types of environments. We're more interested in looking at the visuals and seeing that you understand the fundamentals of making it effective. So I'm gonna close there and leave it to you guys if you have questions. I'll keep sharing if you like. Probably might be useful, but I'll open it up to Davi and others if you have questions for me.
Yeah, Jan, he's asking a question through chat.
Hmm.
I don't know if I should read it or you read it.
Oh yeah, I see. Yes. So this system does not work for non-flat surfaces because The it's not a decal that I'm using for my scorch mark here. It's a sprite. So that ground crack, I'm just placing it. It's a flat piece of art. So if we have a bumpier surface, collisions, no problem. Our rocks would fall, no problem. Our spikes, they penetrate the ground, no problem. But the scorch mark, I would probably need to make a decal that projects onto the contour of that terrain. Was anything needed like to go over again or any uncertainties? I assume certain things that you guys had some knowledge of, but some stuff maybe was a little bit, I blew by too quickly. Dennis has a question, I believe.
Yep. Hello, can you hear me?
Yes.
Yeah. First of all, is this effect scrubbable? Can you just scrub it on a timeline and would the forces follow with the cursor, or is it something that would be kind of random from playback to playback?
This is random from playback to playback because the determinism in Niagara Falls is more expensive, and we'll use that in my experience with a sort of Mortal Kombat universe. We'll only use that if we have like a cinematic. We want that look to be the same. But in gameplay, you usually don't want a repeated look if you fire off an attack over and over again. So one other thing I can show here is when you look in a sequencer, you have a life cycle. So when you bring your Niagara system into the sequencer, you need to create a life cycle, system life cycle. And with that, you can use desired age or tick delta time. And the desired age allows us to do this, go back and forth. But
Yeah, hello, can you hear me?
yes,
Yeah, first of all, is this effect scrubbable? Can you just scrub it on a timeline and would the forces follow with the cursor, or is it something that would be kind of random from playback to playback?
this is random from playback to playback because the determinism in Niagara Falls is more expensive, and we'll use that in my experience with a sort of Mortal Kombat universe. We'll only use that if we have like a cinematic. We want that look to be the same. But in gameplay, you usually don't want a repeated look if you fire off an attack over and over again. So one other thing I can show here is when you look in a sequencer, you have a life cycle. So when you bring your Niagara system into the sequencer, you need to create a life cycle, system life cycle. And with that, you can use desired age or tick delta time. And the desired age allows us to do this, go back and forth, but it jumps around, right? Because it's not deterministic, and it may crash. So I don't use that idea of having it perfectly the same every time. I always assume that it'll be a different cooked look each time it cycles through.
If the determinism is enabled, would it be basically the same as you scrub it? Would it be like fluently flowing from one frame to another if it's deterministic?
If it's
I'm asking because
deterministic, yeah, go ahead.
I'm asking because we often do things like rendering in clusters, so it's not really gameplay, but more like cinematic situation. But also has to be
Yes.
rendered in multiple displays, so it has to stay consistent from frame to frame.
I would use
And
determinism.
yeah, but like just like using determinism in the setup would suffice. Just like using this life cycle desired age and determinism on.
So the desired age, I don't think will affect your render. So what we're doing really is we're playing this, but when you render this, it's going to play it, and it won't care if it's desired age or delta tick. It shouldn't. Determinism in your Niagara system
That's a good question.
will be the key to setting that to be the same across maybe again different machines rendering those parts. I think in that way determinism on your Niagara particles is the key, not how it's set up here on the sequencer. Real quick, I'll answer too. So collisions with other objects like a wall, it's all there. If the object has collisions enabled, then your particles, if they're set up with the collision module for ray tracing, will collide with them. So that's free basically. And then, Dennis was asking, what kind of topics are you planning to cover in the workshop? So I'm not going to get involved with Houdini, but I have some examples that I'll share of shattered geometry, and we'll blow up some things with Niagara using pre-shattered assets from Houdini, or even some point cache data, again, from Houdini, but you don't have to use Houdini. They'll be brought, with me. And then I want to cover things like character attacks. I want to cover things like the the result, the victim getting dissolved away. I want to look at environment effects. Like there's really bad examples of environment effects out there, and they don't have to be. There's some basic things we can do to make like a torch of fire looking really good. And how do you make that for an environment versus, an expensive effect? Or things that are simple too, like, hey, how do we get some good, interaction on water drips and splashes and things that could be used all the time in an environment or cinematic. Probably also dabble into things that are like, let's make a portal. Everyone's making a portal, but can we do something a little bit different? Or some sci-fi teleports. How do we, maybe move away from some of the magic and do something that's a little more tech looking? Some examples of that, or impacts, some of the bare bones of that. So again, it'll be introductory, and then we'll have critiques. At the end, we'll look at trying to get everyone several examples that they could put on a show reel that demonstrate some of these techniques at a high level, but also, if not, just come away with a greater understanding of taking these tools in Niagara and being able to control them deliberately in a way that you can, build on and use either in a game or in a cinematic. I think a lot of Unreal has the potential of doing more real-time rendering, which really just means rendering, but building out these kind of effects in a faster way than you might have with compositing and Houdini and lighting uh, all separately. So, hope that answers that. What I'm showing you today is not difficult, but it may not be intuitive either. Perhaps you wouldn't maybe have known to do certain things. And that's the challenge, is not to start, but to get to an advanced level with Niagara. You want to have a community of people or a classroom to share ideas with or make shared discoveries. I would find that challenging to be isolated and make those discoveries. The documentation for Niagara, like a lot of programmer documentation, isn't talking about how to make cool effects with it. They're just kind of telling you what it does. And like everything in effects, I feel it's a creative process using technical tools that gets you the best results. And to that, I feel like a workshop and having 10 days will allow folks to be able to really get a little further than they could on their own, or certainly, explore feedback. Like every day I'm giving you feedback. And it's not always technical, right? It's like, this looks good, that doesn't. What if we change this? And a lot of that I do obviously for my job, but even in building these examples, take a little time, step back, evaluate with others. What do you see that I don't see, or what could be better? And then you learn, oh, technical bit, I can adjust this, and now the visual works a little better. Real quick, I'll answer too. So collisions with other objects like a wall, it's all there. If the object has collisions enabled, then your particles, if they're set up with the collision module, uh, it's awesome. So I am very fortunate to have migrated from film effects to game effects. I would have wanted this earlier in my career if I knew what I know today back then. If you guys are doing game effects, then that's awesome. If you want to do more or learn more, definitely follow up. I think even in film effects, there are going to be opportunities to take this type of technology and apply it for both cost and also certain, ease of use in a way. There's nothing wrong with Houdini, and there's nothing wrong with Niagara Unreal. Um, but having done both, I'm content to continue pushing real-time effects and finding my little Houdini tricks in ways I can apply them in real time. I'm be excited to share more of that with you guys. So what I was going to say is, traditionally effects artists and using Houdini were hard to come by, and so they weren't going to be available to go and teach, and they weren't good at doing that. So I worked with a lot of talented people who were great in collaborating with, but we're not going to be in front of a lecture of people at the computer patiently showing them how to do these techniques. Um, it's just not in everyone's wheelhouse to do that, especially because some of that technique is very technical and difficult to explain. It's one thing to do it, but then how much do you have to explain for someone to understand it? So you're not just copying what someone did, you're understanding why they did it. That's a little more involved. That's harder to teach. But again, like today with VFX in real time, it's a little less hard, but there's a lot less documented material to use like you could find for Houdini. And so again, I'm glad to be taking time to make some of that content in order to teach it based on some things in the industry. Not everything, but some techniques. And what I look at when I see demo reels, unfortunately, is a lot of those kind of YouTube demonstration pieces that just don't go to the next level and showcasing some sophistication visually. And then usually that's technically then lacking as well. You get both if you get it at all. And so there's certainly in my mind a need to get folks a little farther along to be like a little bit more here, visual and technical will have a really polished demo reel. And those are the kind of things that'll get you noticed for a job or getting the next role on a project or promoting yourself. Again, it's a little bit of seeing what's being offered, and a lot of that has diminished again in the last 6 months, 8 months. But also just seeing that there are needs, like with my company, where we will continue to reach out to other studios to work with their core people, effects people. And they hire just effects people to service other projects, contracts. So I can project not personally what my company at NRS is doing, but just to see what our partners are still, full up, or they don't have more artists for us because they're all being employed elsewhere on other projects. Um, it won't always be that way, but I would suggest it'll always be biased where of all the types of art content creators on a game development program, the visual effects and the technical artists will still be the fewer available because they're the fewer trained because those skills aren't easily being taught in colleges at least. Maybe. Depends on your audience. So, like everything, there are awesome movies with awesome effects, and then there are those that aren't. And I think if your game that you're developing isn't really focused on the effects being important, sure. Um, Whatever you get is fine. And that's how it used to be. I was told from the veterans I work with way back when almost anyone would grab some basic effects and finish off some of those parts. But for folks who want to see something new and exciting and go and buy the game because of that, then you can't rely on a canned looking effect. And that's been true like outside of real time effects. It's been true in general. No director ever wanted to repeat that thing they did before on a previous film. And certainly they wouldn't want some, hand-me-down effect in their movie. So creative directors for, the higher end games are in that same boat. It's like, this isn't an afterthought. We want the effects to be as hot as everything else is in the game visually. And you can't just can that stuff. Even, I think, stylized effects may seem simple visually sometimes, can be equally complicated to create. And I don't know that, again, you're going to keep a customer happy with a legacy of a game title if the effects just look like the last title they shipped. It depends. So if he's comfortable with showing his presentation and the effects are not the selling feature, but yeah, that looks like a fire, or yeah, that looks like some magical sprites, then probably fine. But let's say he wants his character, he's got some distinct character that is supposed to have some distinct powers. It's probably worth pushing the art to get that look correct. So it depends on, like, yeah, environment background effects, they're the first ones to get the low end. And that's why I say they don't have to be. I mean, we can make a beautiful looking torch that you could use as a weapon or an environment effect, but you'll know how to make a real high quality piece. It depends. If the audience doesn't care, then maybe it doesn't matter. But in my world, I feel as though the effects have to match the look of the character and the environment and be um, as much to film quality as that setting they are in. If I were to work on an independent game that's stylized 2D side scroller, yeah, I could probably find stuff and buy a package of effects. I might modify a little bit, but that could cover, maybe 75% of my needs. The actual execution of the effect in Niagara can be very straightforward and simple. The artwork you put on it, like is it a rock or a dust poof? You don't want that to be garbage because Niagara won't help you there. But you have a quality art and you have a solid Niagara setup, then you can get a very convincing look, whether it's photoreal or it could be stylized 2D. I would suggest, like, if we were to start day one of a workshop, we're going to have everything provided to get started. And you'll have some art already. You'll have some static meshes already. You'll have some animated characters already. All that is because it's free on the internet. So I'm not making any of that for you guys. It's just I downloaded it, but collect it together. So anyone can start with those pieces that are free, either on the Epic website or Mixamo for animation, or even some textures are out there. Then we can look at the bare bones Niagara system. So like I mentioned, they have already generated some of these systems and emitters that do certain things. So you can understand how it works without even worrying about the effect visuals. And then we start to assemble what works with what. That's the instruction part. Say, okay, you want to have a fire. We're going to have this fire flip book and we're going to have this cycle of particles and do it a certain way. The next thing you want are shattered rock debris, totally different emitter, and it could be maybe in the same system, like I showed today. But then it's a static mesh. We got for free, and the material it's already there free. So I wouldn't want anyone to get bogged down trying to make effects by doing materials, making meshes, making flip books. They can, but that's after they're comfortable with just the foundations. It's and a lot of layoffs occurred of late, and that's going to pass because this will rebound quicker and better than the film industry. So, yeah, I don't see Unity taking over the landscape either. So Unreal and Niagara for effects and MetaHumans and Nanite, they continue to offer technological solutions that'll then become more mainstream for film, for streaming, all that. And yeah, the effects are still going to be done with Niagara. So eventually we could, you know, get this workshop done real time, but could probably grow into that idea of like take out the real time word and just say, let's work with Niagara and let's work with Unreal. Maybe we'll render movies. Maybe we'll just play it in game. Keep it loosey goosey because the effect of building that will be the same. How you present it could change, be more flexible.